let's go ahead and get started.
Thank you, Candice. Yeah, has been a long time. And I will just walk through briefly through my curriculum vitae. That's Latin. I was born and raised in Israel. Spent about the first 10 years of my life in a kibbutz in the Galilee, and spent a lot of time learning, being outdoors. Then I went to, my family moved to a little town near Haifa, and that's where I went through the high school. Then I joined the IDF because everybody had to, and from there I went to university and kept learning for 3 degrees, one after the other with breaks in the middle. Then spent another 6 years at the Hebrew University of Jerusalem for postdoc, and then came to California as a visiting scientist and decided to stay and worked on a whole bunch of issues that relate to problems in the San Francisco Bay Area. And then I also worked with a consulting firm during that time. In 2000, I moved to work for the state. I was hired as a citizen monitoring coordinator. That was when I was about 50, and I figured it's time for me to teach others what I know. So I spent a lot of time working with citizen monitoring groups and providing training. And in 2006, I retired from state service and created a course at UC Berkeley Extension, where I still teach, and I give that course. It's a 2-day course for quality monitoring design, and it comes on once or twice a year. After retirement, I didn't stop working. I actually worked as a contractor, and I worked on creating interpretive reports for the water boards, both in the San Francisco Bay region and for letting me know. Anyway, I tried to figure out how to tell the story and how to slice it, and I found that there's so many ingredients, and they all belong in different parts of my experience. Then I figured that the best way to actually share experience is to select it horizontally by subject matter. So that's how I structured the talk. So the first thread, the horizontal thread, has to do something with the power of categorization, and that takes me back to very, very previous times. In the early 50s, when my father used to take me out and give me some exercises that made my brain work hard. I sometimes liked it, sometimes didn't, but it was very, very good skill to observe and to be able to separate different things. In high school, I remember an exercise that our teacher gave us where we had to sort out some butterflies, day butterflies and night moths, and again, observation skills and ability to arrange the items according to what they share and how they differ. And that's very, very good skills. It proved to be a very, very useful skill for me because I made use of it when I was studying, and I also I was able to get very good marks because I was able to remember things. I'm jumping now for about 5 decades, kind of in a jiffy. This was developed probably when I was already working here in California, trying to figure out how to organize field measurement data. And one of the first things that I did was to put it in a table that looks like a horizontal table on the top. But in '93, when I was asked to create a database, I was taught that the best way to organize it is to have the characteristic as its own data column, and then describe each result separately. So the vertical or the flat file format was brought into my consciousness, and it took bulldozers to convince me to go from the tabular, the horizontal format, to the vertical. And since then, I've been using my own bulldozers to have other people do that. Because the most natural thing for people when they start tabulating data in a spreadsheet is to do the horizontal structure. Celia. Anyway, so I was talking about sorting and organizing entities in different categories and types. And one of the first things that I was trying to do when I was creating a data management system, a very simple set of Excel spreadsheets, was to be able to describe what kind of characteristic I'm talking about. It could be an analyte, it could be a physical property. And the more important thing when I was writing down the results in a spreadsheet was what kind of result is it? Is it a verbal category, or is it a measure value, or is it an endpoint? And that is a very important thing to communicate when we are communicating data. So there are many, many types of result endpoints. That is, we calculate something and we report that as the bit of information that we want to glean from the database. And it could be derived endpoint for one sample, or an aggregated endpoint for one sample that takes more than one characteristic. We use a lot of descriptive statistics for many data points. We always do the moving, we actually do the mean, the max, median, that's very popular. We also do moving weekly average or other things. And for a lot of situations, we need to rank the results. This is a way to put it in a tabular format that went into one of the publications that I put out. And it turned out to be an overkill. Very few people could actually relate to it, and I understand why, but which is okay. But the take-home message was that the result type and the endpoint type were used by other people. I mean, workers from all areas of inquiry use the same categories and types, but often they have different names for them. But those are unifying concepts. Another example of unifying concepts that I was aware of when I started working, teaching, was that we all use the same sampling design principles, no matter what kind of areas of inquiry or discipline we're in. And they can be broken into deliberate and non-deliberate, and the deliberate is deterministic and probabilistic, and they have different names, but they basically have to do with something we know or systemize, and sometimes some things that are random. The non-deliberate is something that nobody talks about, and nobody attaches that kind of sampling design principle to their data, but they are part of the milieu of monitoring in terms of a lot of the data or selection that we make are constrained, or we sometimes go to collect samples in response to something, and it's not really deterministic or probabilistic. It's a non-deliberate situation. Another thing that I came across when I was trying to get data into some kind of an electronic format in a structural spreadsheet was that people were doing a lot of protocols that involved spatial components, and they were very variable and different with different ways of looking at things. It was very, very difficult to put everything on the same page and create a management system that will show where, in what spatial component each result point was collected. When I try to see what they all share, and we'll talk about streams here, I realize that each one of them can have a backbone, And the backbone, it could be the thalweg or the mid-channel or the centroid. Every protocol will decide what their backbone is. But once you have a backbone, you can actually map your sampling frame much easier because it suddenly goes along some kind of one linear dimension that you could work with. And then if you continue with that sort of thinking, and you go to more advanced protocols with some kind of internal hierarchy, and you have different kinds of components. You have plots, you have riparian plots, you have BMI collection plots, you have in-stream habitat plots, you have transects, you have transect points where you do things. You have a whole bunch of components where you collect the data, and you need to connect each result to the component in which it was created. And it's actually very easy to put it in one spreadsheet and map everything and analyze and include all the results for the different components that when you collect them. I call this system the FlexiGrid, and the important thing about it is that most of our protocols and sampling frames have all these in common. They have cross lines, they have plots, they have backbones, they have different reference points, and so forth. And the terms that I gave it in the FlexiGrid are neutral. It's not protocol dependent, so everybody can use that and then create a spreadsheet with that, map each of the components, and put the data associated with that component. And also have the name in the protocol just so that we know what we're talking about. The search of unifying concept became almost an obsession in the late 2000s because I noticed that people were not talking the same language, but they were doing the same thing. And so I was trying to go through everything I know about monitoring and put together what I think is shared by different areas of inquiry. And this is a partial list. Everybody has sampling design principles. Everybody have some kind of special references to points on the grid. Everybody is using some kind of lines with origin, length, and direction. The importance of tracking and linking entities, station ID or station code or site ID, they're all the same, but they're a very important unifying concept. Sample ID the same. Even database fields and database cells are some of the things that we all share. And measurement systems are also a unifying concept. This is a very important one. And there are even if they measure different things, and you have measurement systems that do just about anything, because they're derived devices and procedures that use for quantitation. And even doing physical habitat assessment, you're using the measurement systems of the tape and the ruler to measure distances and depth, but you also use the brain of the operators to do some evaluations of percent cover and things like that. And every measurement system needs its own quality checks. And you all heard about matrix spike, matrix spike duplicate, so sample arrival temperature, which is the quality check. A lot of people repeat observations or repeat categorical observations, like two field operators say, yeah, the canopy cover is between 30 and 50%. All these quality checks are very different from each other, but all of them are quality checks. And when, again, using the power of categorization, I tried to put them in a table. I saw that they have quite a few categories. And each one is different from the other and distinct within itself. But most of them, everything I think except the inspection and verification, actually have some kind of a comparison, either to a standard or to one measurement to the other. or the blank versus what the value that we're looking for, the spikes. In all the spikes, we put a nominal concentration, and then we see what we got, what we were able to recover, and things like that. So I think that if we look at all these quality checks as comparisons of the first value to the second value, we can see that we can tabulate them and organize them in one table that can accommodate all quality checks. And if you transpose this table, you will get a database table. The important thing is to describe that quality check in all the different descriptors that are necessary, which is the batch, what kind of batch it is, what's the ID of the batch, and so forth and so on. And then you have the expected value, what kind of value we're looking at, and what is the result for that. And then you could get the outcome of the quality checks in different units and ways that you want to describe them. So the ideas of organizing information in one like a universal system came around when I was putting the list of the integrated data elements list that includes everything that we do in different areas of inquiries, and it's all using the unifying concept. And the integrated list is available, and it's work in progress. I keep working on it all the time. I'm going to take a breathe and then go to another thread that I think is very, very important in my development and in the way that I've been expressing my concerns about data. Starting quite early in the game, I was working. I was as an IDF soldier. I was in a special unit, and we were in an agricultural settlement in the desert, and we were doing research on irrigation methods. This was one of the first research projects using the first prototype of drip irrigation systems that were developed in the 67, 68 in the Negev in a kibbutz in Israel. And we were growing tomatoes and cucumbers and other things, but we had like 4 experimental plots for each treatment, and we had different kinds of irrigation systems. And we were told to collect some leaves from plants and measure the length of the leaves, but we were not told how to select each of the entities, like how to choose the plants and how to pluck the leaves from each plant. And I'm sure the instructions were somewhere, but I don't remember reading them. And I don't recall any quality checks. But what I was impressed with is the replication, because that was, how you do experimental research. Many replicates. That gives you a sense of how real yielded results are. Jumping 3 decades to the issues that I had to do with data quality in later life, when I was already working as a consultant and teaching volunteer monitoring groups how to collect field measurements. I went to Reno when the National Water Quality Monitoring Council created its first conference. And one of the things I remember from that is a room full of people where an intern from EPA, a young man, was talking about rounding up data from all over the nation and how much he had to throw away. He was really crying. His voice was shaking, and I felt that it's something that we all need to know and remember, that this is a total waste if we don't do the due diligence of collecting information about the data, and especially the quality of the data. And that was the first time I understood that the program, every program needs a way to make sure that all that information is captured and managed. Otherwise, the program cannot deliver usable data. And the people who are in the program who are doing the work, it's their personal responsibility. One of the things we needed to convince managers in California when we started the surface water ambient monitoring program, that was the year 2000, 2001, is that they need to allocate resources, and they didn't know that. Because it does take a lot to provide information about data quality. And we figured it's at least 15% to quality checks in terms of duplicates, spikes, blanks, etc. We have to let the people who are the operators know that they are personally responsible for what they do. They're not doing it for somebody else. They're doing it for themselves. They have to be proud and own their data. And there is no way around having a savvy person do the data quality assessment for each database, even if the lab does that, and the labs do. There's always issues that we find when we do an external data quality assessment with the lab reports. And then we need to figure out how, how to organize that information. And, and how to share it so that it is discoverable. And this is one of the things that WQX is trying to do now, to make sure that people who mine the database will have access to the quality information. And it sounds complex, but there are people and tools that can help you. Over the years, I developed this internal policeman when I was doing my own measurements or my own research, that it's good to have healthy skepticism about the functionality of every new measurement system. And try it out before I start collecting data for real. With reagent kits, I have to look at the strength of the chemical and find out if I need to dilute the sample. With sensors, I need to understand the range of linear signal and the total range. And if I have different ranges built into the sensor reader, I need to know that too. I want to make sure that the instrument is working by repeating measurements and looking at how it responds and watching how fast the reading change. Just need to understand and characterize the instrument so I feel comfortable collecting data and I know when something is wrong. And calibrate often to reduce the drift. Why do I need to calibrate often? Because drift happens. And this is one of the things that took me a long time to really understand and articulate. This plot has been drawn about 10 or 15 years ago, but it came out in my poster in the last conference in Denver. And until I talk about it with people, they often don't think about it. Because it is a part of the nature of the instrument to drift away from the calibrated state. And we have to see how much it drifted in order to know what is our inaccuracy. That is how far we could be from the truth. And if we do it often, then those increments, those drifts are small. If we spend a lot of time, we're going to be out of range of our measurement quality objectives. I saw that it was only like in year 2000. I was using instruments for about 25 years without really understanding it and without doing post-event accuracy checks. And that's why a lot of the data that I collected probably are questionable. But once I figured it out, we started implementing it in California, and I think that most of the data that we collect now, the citizen groups, actually do the post-accuracy, a post-event accuracy check and record the value, so we have data of known quality. Another thing that was very problematic was aliquoting and splitting samples, composite samples. When I was working as a consultant here in the Bay Area, and we're collecting water samples from storm events, and they were very murky. We had issues with distributing them, and when I was collecting sediment samples that were really patchy, and I mixed it all in a bowl and tried to allocate it into different jars, especially if the sample was wet. Uh, each spoon that I took from the bowl contained something else. So I figured out the best way to um, make sure that all the jars have the same thing is to fill them in increments. And that way there's a better chance that they all have the same mixture of particulates. And of course, mix the bowl every time before I take an increment. Same thing with the liquid. The USGS tell you to use a churn splitter. You could also use a siphon or a pump mix with a very good steering. But the idea is that once you kind of get that flowing, you want to put line up your sample bottles that you need to split the samples into, and fill them in increments, so that even if you have some particles at the bottom, you would be distributing the particles in an even way. There is lots of other things that the internal policewoman taught me, and some of it is coming out in the standard operating procedures and in other products. But I want to move on to the third thread, which I found is extremely important in our monitoring activities and in my life, and that is the communication. And for me, it started when I was very, very young. I was bred in the bone that you need to write clearly and unambiguously. You write a sentence, it needs to be clear. And then I discovered that it's actually very good because it helps the people who are reading my stuff spend less time trying to decipher and more time understanding what I'm saying. And then I had to translate everything I know about writing into scientific papers, and several people that I have to thank for teaching me how to write in this language, the scientific language, especially my PhD advisor. The sensitivity to language, to the meaning of words, was very heightened because I am bilingual. And after making all sorts of mistakes and using the wrong expressions, I realized that I really need to know what I'm saying. And I found that as a scientist, I really need to be clear as well, and it goes together. I'll go back and remind you, most of you have probably seen it. This is the monitoring framework that the National Water Quality Monitoring Council developed in 2002. There are lots of tasks and things to do here. The important things that I was using in my teaching is the 6 cogs of how to actually progress with design through the collection and compiling and managing and assessing and conveying the results and finding that is reporting, and also thinking about what we found, and then redoing the design and changing our questions if need be. So it's a cyclical process, and there is a lot of steps happening in that. When I was doing my own research, and I've been doing that for a couple of decades in Israel as a young scientist, there was only one brain that did this, and things were kind of simple. I did talk to experts, I did talk to some of the stakeholders or the people who might want to use my data or have anything to do with it. But all the functions of the data collection effort were happening in one brain, and that brain was talking to each other. It still does, but not as effectively. But then I came to California, and I started working in systems where many people were involved in data collection. And when several brains need to work together on the same thing, we really, really need um, some kind of ways to have those brains communicate. And one of the things that we do in order to do that is write monitoring plans and other planning documents and create all sorts of other ways of communication and organize data in a way that enables gleaning of information and so forth and so on. But the language of communication is not that simple because we have different cultures, especially in this nation. Became apparent when the council started convening the experts, and they started talking to each other. And we found that every agency have its own version of agencies, and each program has its own dialect of programmese. And if you look at SOPs and protocols from USGS and compare it to what you have from the Forest Service, you need another dictionary. Or you need to create a crosswalk glossary in order to be able to understand what this agency is saying and what it is equivalent to in that agency's language. And in some ways, I am very, very happy that I was part of that because it allowed me to understand what the problems are, but also to be part of the dialogue groups that created a common glossary and other things, and a common list of data elements that everybody could be around. That was agency independent. For example, when we talk about sensitivity, different people use it in different ways, and one of the things I urge my students to do and my groups is to not use the word sensitivity as a measure for the objectives. Just tell me what you're talking about. Are you talking about the text unit or the resolution? A lot of people say this is a sensitive instrument. Do they mean that it responds fast or is it breakable? So being clearer about the language, I find, is very important. Another thing which was a big bummer when I was working with young citizen groups that didn't know much about monitoring or about science in general is the whole concept of calibration. Because the EPA definition was quite confusing. There are two things you have to do when you calibrate your report, and you eliminate. And basically, if you separate it to calibration adjustment, which is when you eliminate the inaccuracy, and accuracy, you need to check it and report it, then everybody can understand what you're talking about. So I've been using the word accuracy check much more than calibration for the actions that we do when we want to check the accuracy. One of the things I did for the state as a citizen monitoring coordinator is creating a data quality management system that includes DQM, that includes fact sheets, guidance documents, and information papers about the different methods that we could use to measure different characteristics. And we focused on the field measurements of the 5 vital signs. And we created the SOPs for some of the instruments that our groups were using, mostly handheld meters and the field instruments and kits. But the important thing was that every SOP needs to provide step-by-step specific instructions. And once you do that, that's what my groups told me, we don't understand the quality assurance project plans. We don't understand the EPA guidance. We need very, very specific step-by-step instructions for each instrument, for each method. So that's what we created. And each of these SOPs introduces it and talks about what instrument this is all about, and then steps to do the calibration and what kind of standards you need and how many points. and then how to do the measurement, and then also, which is something that other SOPs never were never, I couldn't find it in any other SOPs, was actions that you have to do to affect the measurement quality and actions that you have to do to check, and those are two different things. So you adjust the reading when you calibrate, that's affect, and you look at the drift, that's a check. And then actions to record and report, because you have to do that too, and if you don't get instructions, you don't know how to communicate that. Another thing that I find very important in communication is communicating information about the data. One of the things that I found really, really missing when I was looking at data sets from different projects from different entities was that I didn't know the data was collected in a creek or an outfall or a ditch or just outside the sewage treatment plant. And so I needed to make sure that I have information about what kind of station it is and why it was selected and how it was selected. Was it random or was it directed, and so forth and so on. I also wanted to know when it was collected in terms of is it wet weather or dry weather. And one of the issues that we have in California is stormwater flow are totally different animal from dry weather flow. It's a different category of waters. And when you analyze data, you really need to know if it's runoff or not runoff. And if that is not associated with the data, then you have to spend days trying to figure it out when you're doing data interpretation reporting. The other thing that you want to communicate is why did you select this timing? Are you looking for the worst case scenario? Is it routine? What is the design again? And what season are you interested in? So those bits of information should be really, really communicated in a way that is easable, findable, and discoverable. And I believe that they should go into the database. And they could go into the database. This is part of the integrated data elements list that I compiled from different sources. And the chapters are the same as the Water Quality Data Elements Workgroup of the National Water Quality Monitoring Council. The idea is that there is a data field called Station Selection Intent, and then the cell contents could be something that you select from this pick list. It could be fixed station for long term, it could be permit compliance monitoring, it could be source ID, it could be other things. And of course, people can add their own. But if you start with this pick list and everybody's happy with that, and it falls into what people are actually doing, it's very easy to put it in the database because it's already there. And a lot of this was already started by the Water Quality Monitoring Workgroup, the Methods Data Capability Board Workgroup, the Water Quality Data Elements Workgroup in 2001, 2006 to 2006. There was a lot of work there that some of those folks did. I joined the group in 2004 and been working with them for a couple of decades. But as you can see, if you tell me in that database that your sample represents storm runoff, I'm already way, way up there in my data interpretation efforts. So the results should actually be able to speak for themselves. And that piece is from a presentation that I put out in Madison, Wisconsin, in one of the National Water Quality Monitoring conferences. I believe that this is the role of the results, but it's your personal responsibility to help them do that. This is probably the important take-home message that I would like to say, and it might not be really clear, but it's supposed to be kind of a flow of ideas, of thoughts. I had people ask me to designed studies for some questions that they put together, and those questions were a mix of many issues that they wanted to deal with. So the first thing that I learned and taught them is to separate the issues. It's almost impossible to design a sampling effort that will answer multiple questions. You have to break it into separate intents. And for each intent, it could be a very small question. You use that to hone what you want your data to tell. And once you know that, you deliberately select where and when to collect the data, so it represents what you're looking for. Now, I found since I started working with citizens, but even before that, that when I'm trying to fill out a matrix of intent and design for myself, when I'm doing my planning, I find it much easier to explain it to myself and kind of ask myself all the questions and do the critical thinking about, okay, so what am I trying to figure out, and is timing and location going to give me the answer? And then once I've articulated it to myself, it's much easier to share it with other people. And when I published that paper in 2002, I showed it to my friend, the QA/QC officer of the EPA Region 5 in San Francisco, Roseanne. She said, Vital, you're ahead of your time. And she said it probably take a long time before everybody else starts putting all this information into a database. But I hope it's getting to be the time now. I'm jumping to the fourth thread, which is teaching. Here I just want to say a few things about the methods. I don't know how many of you are teaching and how you do that, but I'm a big fan of the Socratic method, and I've used it to create many what I call spiels, question and answer sequences, where I actually get the people to think and to come up with their own answers and then discover the truth. And that way they remember and they understand the relationship between different things much better. I started doing it when I was teaching biogeochemistry in an introduction to ecology course at the Hebrew University when I was a TA, teaching assistant, and while I was working on my PhD. And it turned out to be a very good way of getting people to understand why the sulfur cycles happens, why sulfur goes from one form with one valence to another, and who does it, the different bacteria that need to do it, and what do they need in order to be able to do that, what carbon source, what energy source, what electroacceptors. And it became a board game, and which I used and taught, used for teaching. The other thing that I've been involved with, and I have lots of experience with, and again, I'm not, there's not much advice that I can give, but I think that distance learning courses with interactive multimedia presentations is really helpful in getting people to understand what's going on. And the course that I built for the UC Berkeley extension since 2006, I've been teaching it every year, is something that includes all sorts of skills, but not interactive multimedia because it's frontal. So maybe one day the course that I'm teaching, the water quality monitoring design, will become a distance learning course, but not just yet. Taking it further into products that some things that people can use. I've already mentioned the element recycling game is biochemistry. Another thing that I find really useful in turning into a game was this urban runoff game. I was working on urban runoff toxicity and all the different sources, and I called it rain washed. It's a board game where you have to add, you get a bunch of cards that correspond to the squares of the board, and you have to add them onto the board in your turn in sequence, and then you score points. And it's a strategy game because sometimes if you do this, you score more points than other things. This is a detail of part of the game board, covered with cards. So each of the constituents like copper, lead, and zinc that come from cars have they come from different sources. In the sources in purple, they have pathways that lead them to the waterway with rain or without rain, mostly with rain, because that's the main vehicle of transport of pollutants into our waterways. And once they reach our waterways, our streams or the creeks or the lakes, they create a problem, they create a calamity. They kill fish, they create toxicity, other things. And there are several things that we can do along the way to either reduce the output, like carpooling, or intercept them along the way to strip out some of the, or to prevent some of them from reaching the environment. And strategy is about how to get the bonuses without without going to calamities. Because if you get lots of points for the calamities, you are not allowed to do the bonuses and so forth. It was very interesting to watch my colleagues, the regulators of the water from the water boards, play this game with the regulated community, the stormwater water programs managers. In a meeting, and how they kind of looked at each other and tried to figure out how to what would be the best strategy for the game and for life. Another thing that I mentioned earlier was a FlexiGrid. It's another tool that came out, and here I'm talking about a little bit about how it was used. In fact, it was very, very helpful when we were, I was using it with my colleagues, my team at the Regional Water Quality Control Board, the San Francisco Bay Regional Board. And they had a lot of data for physical habitat assessments, and that could not fit into any protocol because they were using the intern protocol and the surface water ambient monitoring program, we refer to here as SWAMP. It was did not have a data management system for that. So we use the spreadsheets to work with the existing inter protocols and actually analyze the data and get the endpoints and analyze the data and report it, and then also later to get the data in the field and move it directly into SWAMP once SWAMP is ready for it. So this was my 5 main threads. Here is a bottom line advice for the professionals. Something about owning your data, about taking personal responsibility, about communicating with the people who are going to be using your data and making sure that you don't leave holes in there, that they will find a gap. And the most important take-home message: representative does not happen. You have to make it happen. And that the data elements are the foundation of information management, and that critical thinking is always important. I'll be 70 years old next week, and I can feel it. It is difficult. The database is full to the brim. The search engine is slow. Processing speed is slower. Synchronization is iffy. Operating system, I have to restore it every now and again, like go to the Eastern Sierra or do some artistic work, but there is still a lot to do. Thanks for listening. And if you want to get rid of me, sorry, yes, if you want to get rid of me, I'll stop in a minute. Not before I say that there is a website with a lot of my publications, manuscripts, so a lot of the things I said is already up there, and it's available. And you can also contact me with any questions.